Okay, all right. So today we're going to begin the second day of the new unit from Unit 6, which is graphing systems of linear equations. Okay, it's a lot of words. So yesterday we were doing it by hand, right? Old school style. So today we're gonna do this new school style, which is showing you how to do it on a calculator, meaning how to graph it on the calculator, and at the same time find the solution from the calculator. And there are several ways to do that. Okay, so let's see what that looks like. Let's go. Okay, all right. So now, sometimes I plan these things months ahead of time. So I was preparing to get ready to shoot this video, and somehow I included the answers here, and I'm trying to backtrack for like 2 months, trying to think of the reason why, and I can, but so I'm making up new reasons for this. Okay, all right. Anyways, doesn't matter. So what we're gonna do is this. So today we're going to talk about graphing systems, but on a graphing calculator. So without any further ado, all right, we are going to go straight to the calculator. Again, you can see I cleared the RAM. All right, it's always good practice to do. All right, especially the day of the Regents exam, by the way. All right, you have to clear the RAM. Okay, negative 2x minus 8, right? Negative 2x minus 8. And the other equation is negative x. By the way, if you're typing on the keyboard, don't type minus. See the difference? That's wrong. The system's gonna kick back and say like you had a syntax error, which means you've just put in the wrong symbol. What is it? Negative x plus 5. So what we're gonna do is this. We're gonna do two examples together, and then we'll come back to class and practice. Okay? Now, I'm just right off the bat. Whenever I do these, all right, it's like baking bread. When I'm done baking bread, I've never baked bread before. When I'm done baking bread, I want to look in the oven, right, and see if the bread is ready, right, if it's golden brown. So same thing. I want to see the graph first. Now, this graph is not great. As a matter of fact, I just did this before. How am I so off? Negative 2x plus 8. Oh, it's plus 8. That's why. All right. So let's see, negative 2x plus 8, negative, yep, okay, all right, let's go back to the graph, okay? There we go, much better. Now, here's the thing, right? Look back here. I got the screen here, and I also got the third screen, right? So here we got the equation, the graph, and lastly, the table of values. So, and I think the reason why I put this over here was because you can see, like, it's really hard to spot sometimes, especially the picture's grainy or for one reason or another, is very hard to see exactly where the 2 points are intersecting, right? I got two strategies for you. One is super duper simple. So you go to second and the graph. So I want to see the table values. So second table. Here I got my table values. Now I can go to back and show some negative numbers, whatnot, right? So I got 5 negative numbers, 0, and 5 positive values for x, right? Or the domain, all right? Remember that word? So now what I'm looking for is this, because the x values doesn't change, right? Like you have to go through putting in, these negative values, the same 0, the same positive values for both lines. So what I'm looking for is in y1 and y2, the two y values, I'm looking for the set of two numbers where they share the exact same y value. Because if they share the exact same y value in the same row, then they're sharing the same x value also, right? Because they both share, so here they both share 5. But the thing is, for the blue line, when x is negative 5, y is 18. But for the other line, right, for the red one here, right, our blue line, our red line, for the other one, when it's negative 5, the value is 10. So on and so forth, right? So look here. When x is 0, y is 8. So the y-intercept for the blue line is 0, 8. The y-intercept for the red line is 0, 5. So that's not it, because the only time they're going to share a coordinate right here is when they have the exact same coordinates, right? That's the definition, right? If they share the same coordinate, that's where the two lines touch, right? So if I go back to the table of values, and I go down to where x is equal to 3, oh, look, there you go. 3 comma 2 for the blue, 3 comma 2 for the red. So they both share 3 comma 2 at the same time, right? And that explains this right here, this point right here, okay? So that's the first way. The second way is to actually trace the graph. So what we can do is this, all right? If you want to, you can just start moving the arrow as soon as you hit the graph. So one more time, right? So let's say we got the equation, graph. Just move the cursor, right? By pressing the directional buttons, all right? So I'm gonna go up there. I'm just gonna get very close. Now, here's the thing, right? I mean, these numbers, they're decimals, but you can see they're close. So if you want to investigate further, here's what you do. You can do one of two things. You can trace, right? And so what I'm doing is just tracing the blue line. All right, so I got somewhere down here, right? Looks like it's 3, 2. If you want to look even closer, so the first thing, again, is to trace it, right? If you want to look even closer, you can zoom in. So I'm going to zoom in, enter, right? You see the flashing target, right? So the question is this. So basically, the reason why this is a flashing target is because the computer, the calculator, wants to know, hey, where do you want to look really close, right? Because you don't want to look very close all the way here on the left side. There's nothing there. So press enter, all right? Right? Getting closer, right? So look, I'm still I'm not tracing anymore, but that's okay. I just want to get really close. I mean, look here. Look how close that is, right? This is 3, 2. Now, if you're like me, you want to keep zooming in because you want to be as close to the exact answer as possible. You can zoom in again. Zoom in. Again, flashing target. So I'm going to press enter again to zoom in even more. Oh, look how close we are, right? So let me scroll down a little. Wow, look at this. Like, you cannot get any closer than what we have here, right? 3.001, so that's 3. 2.004, so that's 2. 3, 2. There it is. There's our answer. And that's how you do that, okay? All right. Now, that said, so the solution here, right, and that's what we call it. The solution is 3 comma 2. That's where the two lines intersect. That's where the two lines intersect. Now, starting in a couple of days, we're going to actually solve this using equations. Okay? So very, very cool. All right? And I'm going to try to come back here to show you how to do that. Now, down here, you see how I wrote the same equation? Some of you might be looking at this and saying, Mr. Englight, these two equations look nothing like each other. How can you say that they're the same? But they're the same, right? Remember, this is in standard form, right? Ax plus by equals c. This one is in slope-intercept form. That's y equals to mx plus b. So if you were to perform, all right, some literal equations, you will get the same answer, right? Look, I'm solving for y, so I subtract 4x on both sides. So that's 2y equals to negative 4x plus 16 divided by 2. Y equals to negative 2x plus 8. Same equation. Okay, and for the interest of time, same equation. Okay, when you do the literal equation. Okay, so that's today's lesson. Come back to class. We'll practice with these questions, and that's it. Okay, all right. See you in class.
OMG, that was so good.